All right, today we're going to pull back the curtain on one of the most fundamental yet kind of invisible parts of the internet, back-end routing. Seriously, think of it as the ultimate digital traffic cop, directing every single click and tap you make to its correct destination. Let's dive in.
I mean, it really does seem like magic, right? You ask for a specific user's profile, and boom, there it is. You search for a product, and the search results just appear. So how does the server sort through all of this chaos? Well, that's exactly the problem that routing is built to solve.
So, to really get this, let's think of every request you send out into the digital world as having its own built-in GPS. It needs to know not just where to go, but also what it's supposed to do once it gets there.
And it turns out every request really just boils down to two simple parts. First, you've got the what. That's your intent. It's expressed by something called an HTTP method, like get if you want to fetch data, or post if you want to add new data. And second, you have the where, the specific resource you want to mess with, like /users. It's the combination of these two that gives the server a complete, actionable instruction.
So, that's routing in a nutshell. It's the process of taking that what and where combo and mapping it to a very specific set of instructions on the server. The server looks at both the method and the path to find the one exact piece of code that was written to handle your specific request.
All right, so now that we've got the basic idea down, let's look at the two most common types of paths or routes you're going to see out there in the wild. This is where it starts to get really practical.
First up, we've got static routes, and these are the simplest of the simple. A static route is just a fixed, unchanging address, kind of like a website's homepage. So, for example, a request to get/API/books is a static route. It will always go to the logic that fetches the entire list of books. It's totally predictable and constant.
But what if you don't want all the books? What if you want just one specific user out of thousands? That's where dynamic routes come into play. See, instead of a fixed path, a dynamic route has a part that can actually change. This flexibility is what allows us to create routes that can fetch specific individual items from a huge collection.
And that little variable part, it's got a special name. It's called a path parameter. In the code, a developer might write something like /users/ID. That ID part is just a placeholder. So when your request for user 123 comes in, the server grabs that 123, sticks it in the ID variable, and uses it to find that exact user in the database. Pretty clever, huh?
Okay, path parameters are super powerful, but they're not the only way to send extra info in a URL. There's another type that's just as important, but it serves a completely different purpose. Let's see how they stack up.
You can really see the difference laid out right here. A path parameter, like /user/123, is part of the core address itself. Its job is to identify a specific thing. A query parameter, though, that comes after a question mark, and it's used to filter, sort, or modify the results. It's like telling a librarian, hey, I want the books, but only show me page 2, or sort these books by author.
Exactly. This quote nails it. The path users/123 has a clear meaning. You want user 123. It's all about identity. Query parameters, on the other hand, like query page equals 2, they're about customizing your view of that resource list. They don't change what you're asking for. You still want books, just how you want to see them.
All right, so now that we have our building blocks, our static routes, our dynamic routes, and our parameters, we can start building some really complex real-world systems. Let's look at two critical patterns for this: nesting and versioning. Nesting is it's beautiful. It's all about showing relationships between your data, and it's incredibly intuitive. You see, you start with all users. Then you can drill down to one specific user, 123. From there, you can ask for all of their posts. And finally, you can pinpoint post 456 that belongs only to that user. It creates this logical, human-readable hierarchy that just makes sense.
Okay, this next one is a huge deal in software development. Imagine you've built an API and thousands of different apps all rely on it to function. Now you need to make a major change. How in the world do you do that without causing total chaos for everyone?
Well, the answer is actually pretty elegant. It's called versioning. We simply add a version number, like v1 or v2, right there into the route. This lets us introduce major updates, or what we call breaking changes, in v2, while keeping v1 totally active and unchanged for all those older apps that still depend on it.
So why go through all this trouble? Well, versioning creates a stable, predictable environment, which is absolutely critical for business. Developers who use your API can see there's a new version available and they can plan to upgrade on their own schedule. And this lets you, eventually, safely retire the old version once you know everyone has moved over.
So we've designed all these perfect routes, this beautiful, organized system. But what happens when a user makes a typo or asks for a page that just doesn't exist? You gotta have a safety net. Let's say we only have V1 and V2 of our product's API. If someone comes along and requests V3, our server is going to go through its list of defined routes and find absolutely nothing. It has no match. And without a plan, this could just throw a confusing, ugly error back at the user.
This is where the catch-all route comes in to save the day. It's the very last route the server checks. That /r* syntax basically just means, hey, match anything at all that hasn't been matched yet. Its only job is to intercept these lost requests and send back a helpful, sorry, we couldn't find that message.
And yep, you guessed it, this is the mechanism behind that famous error message we have all seen a million times, the 404 not found. See, it's not just a random error, it's the catch-all route doing its job perfectly.
So when you put it all together, from static and dynamic paths to nesting and versioning, routing is truly the invisible skeleton that gives structure to the entire web. It's what turns a chaotic sea of random requests into an organized, logical, and powerful system that allows all of our favorite apps to even exist.
And that's back-end routing for you. It's one of those fundamental concepts that once you get it, you'll start seeing it everywhere. So the next time you're scrolling through an online store or your favorite social media app, just pause for a second and think, what do the routes look like behind the scenes here? It's a pretty fascinating peek under the hood of our digital world. Thanks for tuning in.